So let's spend a little bit of time on naming compounds. So first, let's look at some of the common cations. This list basically includes all of the cations that you should be familiar with. Particularly, I want you to note the polyatomic ion, which is ammonium ion that you will need to know the formula and the charge for. And many of the other ions, you can actually predict the charge based on the location in the periodic table, right? So group 1, you would find +1, group 2, +2, but then note that silver ion, which is in the transition metals, but as an exception, only carries a +1 charge. Zinc ion only carries a +2 charge. These ions that are in bold are the ones that you'll see most commonly, and so you want to be familiar with those. The anions, again, the ones in bold are the ones you should be most familiar with. Make sure you're aware of the formula for hydroxide ion, as well as these polyatomic ions that are in bold. You will need to know the names and the formulas for those. So how do we go about writing formulas or naming compounds that contain these ions? So you start with the name of the cation, and then the anion would change the ending to "ide." So for example, sodium chloride or potassium fluoride, etc. Otherwise, if it's a polyatomic ion, you just use the name of that polyatomic ion. If the cation is a transition metal, or some of the group 4A metals or group 14 metals, and it's possible there's more than one possible charge, so you need to specify the charge as a Roman numeral next to the name of that metal. There are a couple patterns that you'll notice for the polyatomic anions that you should be familiar with. For example, sulfate, which is SO4 with a -2 charge. Sulfite is SO3 with a -2 charge. So when the ending is in "ite," it has one less oxygen. If it has one more oxygen, then it's 8, and if it has one more than 8, it becomes per, and then 8 at the end. If it has one less, it becomes hypo, and then "ite" at the end. So it's a pretty easy pattern to see after some time and familiarity. Finally, you do want to be at least comfortable with naming acids. Hydrogen chloride is called hydrochloric acid. So if the ending is "ide," you change the ending to "ic" and add the prefix hydro. If the ending is "ite," then you would change it to "us." So hydrochlorous acid, hypochlorous acid, chloric acid, because the chlorate ion is present. Or when the perchlorate ion is present, is perchloric acid. When you have two nonmetals, and there's only two elements, we refer to that as a binary covalent compound. And generally you start with the less electronegative atom, so it's generally from left to right in the periodic table. And you have these prefixes that you would have to be familiar with. The prefixes is used to tell you how many atoms of each element is in the compound. The only exception is mono is not used for the first element. So CO2 is carbon dioxide, not monocarbon dioxide. It's just carbon dioxide. The second element is going to end in "ide," right? So as we said, carbon dioxide, or CCl4 would be carbon tetrachloride, tetra meaning 4. Generally, they don't use two vowels like A or O together, so dinitrogen pentoxide, not dinitrogen pentaoxide. So just be aware of that in terms of spelling. Finally, there's not a large emphasis on organic compounds, but it is in your best interest to be familiar with the naming, which follows its own pattern. You basically count the number of carbons, and that tells you the prefix. So 1 carbon is meth, 2 carbons eth, 3 carbons prop, 4 is bute, and then they follow the Greek system that you're familiar with: pent, hex, etc. So ane refers to there only being single bonds between carbons. So methane, ethane, propane, etc. If there's a special group, you would actually have, for example, this is called a functional group, and it identifies the class of compounds. So alcohols have this OH, oxygen single bonded to hydrogen, in the compound. So now we put a suffix to represent that. So this is meth for 1 carbon, methanol, ethanol, propanol. And in this case, this number tells me that the special group is located on the first carbon, because once you have 3 carbons, there is more than one possible position. It could have also been on the middle, in which case it would have been 2-propanol. I'll stop there for now. We can spend more time examining this in class. Hope this helps. Bye.
Do you like my drawing? Mommy, do you like my clock drawing?